A black hole tears a star into a ribbon of superheated gas. This violent beauty hides a simple truth: the cosmos is filled with lethal wonders. We are about to tour the 25 most dangerous places in the universe, locations that make Earth's volcanoes and deep oceans seem tranquil. You will discover the specific, terrifying physics that makes each spot an instant death trap, from stars with surfaces of solid iron to voids of absolute nothingness. How can a cloud of gas be more dangerous than a star? What kind of gravity can twist space itself into a knot? The answers reveal a universe of spectacular hostility. Which of these cosmic horrors do you find the most unsettling? Our own star harbors a lethal secret just beyond its visible surface. The sun's corona is a halo of wispy light seen during a total eclipse, a beautiful sight that hides a terrifying reality. This outer atmosphere is hundreds of times hotter than the sun's surface below, a paradox that has baffled scientists for decades. How can the air above a fire be hotter than the flames themselves? The leading theory points to the sun's complex magnetic fields, which constantly snap and reconnect, releasing colossal amounts of energy in a process known as nanoflare heating. This superheats the thin solar gas into a state of matter called plasma, a swirling storm of charged particles. From this perpetual inferno, the sun constantly exhales. The solar wind is a relentless supersonic stream of this radiation and particles, flowing past Earth and out to the very edges of our solar system. But sometimes the sun does more than exhale. It screams. A coronal mass ejection is the solar system's most powerful eruption, a billion-ton cloud of magnetized plasma launched into space at millions of miles per hour. If one of these events were to directly hit a spacecraft, its delicate electronics would be instantly fried, and its metal hull would be scoured and vaporized. This is not a place of gentle warmth, but a raging, radioactive tempest where magnetic forces tear atoms apart. It is a perpetual storm of atomic fire, a death trap that makes our hottest industrial furnaces seem as gentle as a candle's glow. That solar tempest is a localized danger, but the death of a star is a cataclysm that can sterilize entire star systems. When a star many times more massive than our sun exhausts its nuclear fuel, its core collapses in less than a second. This collapse triggers a titanic rebound, a shockwave of almost incomprehensible power that blasts the star's outer layers into space. This is a supernova, and its initial blast wave is one of the most violent events in the universe. The energy released in that single moment outshines an entire galaxy of billions of stars. The shockwave itself expands outwards at a staggering fraction of the speed of light, a wall of pure force. Long before the physical debris from the exploded star arrives, two invisible killers race ahead at the speed of light itself, intense gamma radiation and X-rays. This initial pulse of high-energy radiation would be utterly lethal to any life in its path. Imagine a planetary system bathed in a flash of light a billion times more powerful than our sun. For any world within dozens of light years, its atmosphere would be chemically scorched, its surface baked by radiation that shatters DNA and complex molecules. The cosmic sterilization is instantaneous and absolute. This is not merely an explosion, it is the universe hitting a reset button, wiping the slate clean across a volume of space so vast it defies human comprehension. What could possibly survive such an apocalypse, and what new dangers might be born from the ashes of a star's destruction? The ashes of a supernova do not simply drift away into nothingness. They can collapse into something far stranger and more dangerous than the original star. A neutron star is the universe's ultimate compression, a ghost of stellar matter so dense it defies all common sense. Picture an object with the mass of our entire sun, but crushed into a sphere no larger than a city on Earth. A single sugar cube of this material would weigh as much as every human on our planet combined. This impossible density creates a gravitational pull so immense it warps the very rules of physics. If you were to fall towards one, the pull on your feet would be billions of times stronger than the pull on your head. You would be stretched into an impossibly thin stream of atoms, a process physicists call spaghettification, long before you even made contact, but the surface itself is a landscape of pure terror. It is not gas or rock, but a crust of iron nuclei packed into a perfect crystal lattice, a solid surface harder than diamond, floating atop a sea of supernatural fluid. The magnetic field surrounding this object is a force of pure destruction, 1,000,000,000,000 times stronger than Earth's protective magnetic bubble. This field is so powerful it could tear the electrons from your atoms from thousands of kilometers away, disassembling you into a cloud of subatomic particles before you even knew what was happening. This is not a planet or a star, but a cosmic atom smasher, a place where matter itself is forced into forms it was never meant to take. That neutron star's impossible density is only a prelude to a far more absolute form of destruction. A stellar mass black hole takes this gravitational tyranny to its ultimate conclusion. Its event horizon is the final border, a one-way membrane from which not even light can escape. Crossing this threshold is the universe's most permanent decision. There is no return, no rescue, and no signal you can send back out. But the journey to that point of no return would be a uniquely terrifying demise. As you fell feet first towards a black hole just a few times the sun's mass, the difference in gravity between your head and your feet would be catastrophic. Your body would be stretched into a long, thin stream of atoms, pulled apart molecule by molecule. Physicists call this spaghettification, an almost playful name for a gruesome physical reality. You would be compressed laterally while being stretched longitudinally, transformed into a human-shaped noodle of elementary particles, but the true mind-bending horror involves time itself. As you accelerate towards the event horizon, your perception of time would slow down relative to everyone else in the universe. For you, a final second might pass as you cross the threshold. But for any observer watching from a safe distance, your approach would appear to slow to an infinite crawl. You would seem to freeze in place, a ghost forever etched on the edge of darkness, your final moment stretched out over years, decades, and then centuries. You would die alone in a fraction of a second, while the outside world aged millennia without you. It is a death that warps the very fabric of reality, a solitary end at the edge of forever. Yet the solitary horror of a small black hole is dwarfed by the sheer spectacle of a supermassive one. At the heart of our own Milky Way galaxy, Sagittarius, a star, holds court, a behemoth with the mass of 4 million suns. But the true danger zone is not the event horizon itself. It is the frenzied, luminous storm that surrounds it, the accretion disk. Picture a cosmic hurricane, a maelstrom of gas and dust so vast it could swallow entire solar systems, all spiraling inward at nearly the speed of light. This is not a gentle glide into darkness, but a violent, chaotic traffic jam on an unimaginable scale. The material in this disk is compressed and heated by immense friction and tidal forces, raising its temperature to millions of degrees. It glows with the energy of 1 billion stars, a searing beacon of X-rays and gamma rays that would instantly vaporize any matter that ventured too close. This is a place where the very concept of solid matter becomes meaningless, where asteroids, planets, and even stars are torn into their constituent atoms and swirled into a superheated soup. The forces at play here are so extreme that they accelerate particles to relativistic speeds, meaning they travel at a significant fraction of light speed. To be near this disk is to be bombarded by a continuous, lethal hail of radiation and high-energy particles, a ceaseless storm that represents the final, furious blaze of light and energy before matter vanishes from our universe forever. This is the universe's most brilliant and violent graveyard, a place where physics is pushed to its absolute breaking point. Even the neutron star's crushing gravity is outmatched by a different kind of cosmic monster. A Magnetar is a neutron star that has perfected the art of magnetic violence. Its magnetic field is 1,000 times more powerful than that of a standard neutron star, making it the strongest known force of its kind in the entire universe. This is not a simple pull, it is a pervasive, invisible energy so intense it warps the very nature of empty space. To get close, even from a distance of 1,000 kilometers, would be fatal. The magnetic field is so strong it would not just pull on you, it would distort the atoms that compose your body, stretching their electron clouds into useless, elongated shapes. Your biochemistry, the very foundation of life, would cease to function in an instant, but the true danger of a magnetar lies in its instability. The unimaginable pressures inside these stars cause their solid iron crusts to fracture. These are starquakes, seismic events on a scale we cannot fathom. When the crust of a magnetar shifts, it releases a cataclysm in a flash. The star unleashes a gamma-ray burst, a focused beam of pure energy that for one brilliant second can outshine every star in our galaxy combined. If such a beam were to sweep across a planetary system thousands of light years away, the effects would be apocalyptic. It would not scorch the surface, it would attack the sky itself. The radiation would chemically tear apart the planet's ozone layer, stripping away the protective shield that filters out a star's deadly ultraviolet light. The surface below would then be bathed in a sterilizing glow, wiping clean any complex life that had evolved there. This is a danger that transcends distance, a single cosmic event capable of ending worlds from across the galaxy. The focused beam of a magnetar is terrifying, but it is merely a warning shot compared to the main event. At the very heart of a gamma-ray burst lies a cosmic particle accelerator of almost unimaginable power. These are not explosions that expand in a sphere like a supernova. Instead, the cataclysm is channeled, focused into two narrow jets of energy that scream into space at over 99.9% of the speed of light. These jets are born from the most violent births in the universe, the collapse of a hypergiant star into a newborn black hole, or the final spiraling merger of two neutron stars. All the energy of a supernova concentrated into two laser-like beams. If you were to view this event from the side, it might seem like a bright but otherwise normal stellar explosion. But if your planet were unlucky enough to be staring down the barrel of one of those jets, the consequences would be instantaneous and absolute. From thousands of light years away, a distance that should offer safety, the sky would suddenly host a second sun, a point of light blazing in gamma rays and X-rays. This is not mere sunlight, it is a torrent of high-energy radiation that would strike the planet's atmosphere like a physical blow. The radiation would not just heat the air, it would fundamentally rework its chemistry. It would rip nitrogen and oxygen molecules apart, forcing them to recombine into nitrogen dioxide, a brown, toxic gas. The sky would literally cook, transforming into a smog-filled ceiling that blots out the sun. A perpetual, gloomy twilight would descend, and the planet's protective ozone layer would be obliterated. The surface, now exposed to the full fury of its own star's ultraviolet radiation, would become a sterile wasteland. This is not an impact or a firestorm, but a systematic poisoning of an entire world's atmosphere from light years away. It is the universe's ultimate sniper rifle, a single, precise shot that can end a world story without ever touching its surface. This atmospheric apocalypse from a distant star is a sobering thought, but our own cosmic neighborhood holds a stark warning of how a world can turn against itself. Just next door, the planet Venus presents a vision of hell made real, a permanent monument to the runaway greenhouse effect. Its beauty from afar is a lie, a thick blanket of brilliant clouds hiding a surface of pure fury. The pressure at the ground is 92 times greater than the air pressure we experience on Earth. To stand there would feel like being submerged a full kilometer beneath the ocean's surface, a crushing weight that would instantly collapse a nuclear submarine. This immense atmosphere is almost entirely carbon dioxide, a gas that acts like a one-way heat trap. Sunlight filters through the clouds, but the heat it generates on the surface cannot escape back into space. The result is an oven that never cools. Surface temperatures soar to nearly 900 degrees Fahrenheit, hot enough to melt lead and turn zinc into a puddle. Any metal structure would quickly soften and deform, while any complex machinery would simply cease to function. And then there are the clouds themselves. They are not made of water vapor, but of highly corrosive sulfuric acid, a burning mist that would eat through skin and metal with equal ease. This is not a world of fire and lava, but something more insidious, a global pressure cooker where the very air is a toxic, superheated fluid. Venus shows us that a planet's greatest threat might not come from the outside, but from a delicate balance within its own sky, tragically and permanently broken. Venus shows us a world poisoned by its own atmosphere, but some planets face a far more external threat. Jupiter, the solar system's king, is wrapped in an invisible cage of pure radiation. Its magnetosphere is the largest structure our Sun orbits, a colossal magnetic bubble so vast it could contain the Sun itself with room to spare. This immense field acts like a superpowered version of Earth's Van Allen belts, but on a truly monstrous scale. It captures charged particles from the solar wind, accelerating them to nearly the speed of light and trapping them in a donut-shaped zone around the planet. The result is the most intense and lethal radiation environment in our entire solar system. For any unshielded human, a visit to these radiation belts would be an instant death sentence. The dosage is millions of times more powerful than a lethal medical radiation exposure. It would shred DNA, destroy the central nervous system, and shut down the body in a matter of seconds. But the danger extends far beyond biology. This radiation is a nightmare for our technology. The high-energy electrons and protons can punch straight through the hardened metal shielding of a spacecraft, causing electrical arcs and frying delicate computer chips. NASA robotic probes, like the Juno spacecraft, must carry their sensitive electronics inside a thick titanium vault just to survive their brief orbits through this hellish zone. Without that protection, the spacecraft's brain would be cooked into useless silicon in a single pass. This is not a storm you can see or feel, but an invisible, omnipresent hail of atomic shrapnel. A permanent, seething barrier that makes even a flyby of the gas giant one of the most daring maneuvers in space exploration. While we shield our probes from Jupiter's radiation, one of its own moons endures that hellish bombardment while simultaneously tearing itself apart from within. Io is a world in a state of perpetual self-destruction, the most volcanically active body we have ever discovered. Its surface is a chaotic canvas painted in lurid yellows, oranges, and reds, colors that come from sulfur and sulfur dioxide frosts, compounds that are highly toxic and constantly renewed. This moon is dotted with hundreds of active volcanoes, some spewing fountains of molten rock dozens of miles high, so tall they briefly throw material into the vacuum of space. The driving force behind this incredible activity is not internal heat, but the brutal gravitational tug of war between Jupiter and its other large moons. As Io is stretched and squeezed in its orbit, its interior is kneaded like putty, generating immense friction and heat. This keeps its rocky mantle in a largely molten state, which then erupts violently through any crack or weakness in the brittle crust. The entire moon is essentially being tidally flexed, a process that generates so much energy it completely resurfaces the world, erasing any impact craters with fresh rivers of lava and blankets of volcanic fallout. And all of this geological fury takes place under the unblinking eye of Jupiter, with the moon being continuously scoured by the gas giant's intense radiation belts. Io exists in the heart of the solar system's most dangerous neighborhood, a place where the very ground is trying to escape into the sky while the sky itself is trying to kill you. How can a world withstand such constant violence, and what other hidden dangers might be churning beneath its tortured surface? Titan's lakes hold a different kind of danger, one born of a deep and alien chill. On this hazy moon of Saturn, the principle that defines our own world is inverted. Water is as hard as rock, and the flowing rivers and vast seas are composed of liquid methane and ethane, hydrocarbons that are natural gases here on Earth. The temperature here is a cryogenic -290 degrees Fahrenheit, a cold so profound it makes the polar ice caps of Earth feel like a tropical paradise. At these temperatures, the very air becomes a threat. There is no breathable oxygen, only a dense atmosphere of nitrogen, and any exposed water from a human suit or spacecraft would instantly freeze into a substance harder than granite. But the most immediate peril comes from the lakes themselves. Imagine a landscape where the very ground you walk on could instantly dissolve organic materials, and the liquid that fills the seas is a powerful solvent capable of breaking down complex molecules. And then there is the air. With so much flammable methane evaporating into the atmosphere, all it would take is a single spark to ignite the entire sky. A single electrical discharge from equipment or even a static shock could trigger a conflagration that would race across the methane-rich air, creating a firestorm in a world without oxygen. This is a world where the very fluids are explosive, the cold is weaponized, and the sky is a fuel air bomb waiting for a single errant spark. It is a beautiful orange-hued nightmare of chemistry gone wrong, a place that reminds us that danger is not always about heat and pressure, but can also be found in the deep, silent, and explosive freeze. That silent, explosive freeze on Titan is a contained danger. To find a desolation of an entirely different magnitude, you must journey beyond the protective disk of our galaxy and into the void between galaxies. Here, in the intergalactic medium, you will find a vacuum so profound it makes the emptiness of our solar system seem as crowded as a city street. On average, there is less than one single atom in a space the size of a typical classroom. This is a near-perfect void, a nothingness that defies human experience. The temperature here is just a fraction of a degree above absolute zero, the theoretical point where all molecular motion ceases. It is a cold that is more than an absence of heat. It is an active, draining cold that would suck the warmth from any object in an instant. But the true, insidious danger of this emptiness is not the lack of air or the cold. It is the complete and utter isolation. If you were stranded here, the nearest star would be so impossibly distant it would appear as just one faint point of light among countless others, with no hope of ever reaching it. You would be utterly alone, adrift in a sea of black so vast that entire galaxies would look like small, fuzzy smudges. And into this perfect stillness scream the universe's most powerful natural accelerators. Unimpeded by magnetic fields or atmospheres, ultra-high energy cosmic rays, atomic nuclei traveling at almost the speed of light, would rip straight through your body and any ship you might be in. These particles carry the energy of a professionally thrown fastball, but concentrated into a single subatomic projectile. They would shred your DNA and damage your brain tissue, causing a slow, irreversible decay of your body and mind. This is not a quick death by impact or explosion, but a lingering, cold, and lonely end, where you are simultaneously frozen, irradiated, and utterly forgotten by the universe. It is the ultimate expression of cosmic indifference. This frozen isolation is not always confined to the deep void, for sometimes it comes packaged as a world. Rogue planets are cosmic orphans, worlds that have been violently ejected from their parent star systems and now drift alone through the blackness of interstellar space. On the surface of such a world, the concept of day and night is meaningless. The sky is a perfect, unbroken canvas of black, punctuated only by the faint, unmoving pinpricks of distant galaxies. There is no sunrise, no sunset, no star to cast a shadow. The only light is the feeble, cold glow of the planet's own internal radioactivity, if it has any at all. This is a darkness more absolute than any cave on Earth, a perpetual midnight that has lasted for billions of years and will continue for billions more. The temperature here plummets to just a few degrees above absolute zero. At these depths, the very air we breathe would freeze solid, falling to the ground as a blizzard of oxygen and nitrogen snow. Any atmosphere the planet once possessed has long since collapsed into an icy crust, leaving the surface exposed to the perfect vacuum of space. This is a world without weather, without erosion, and without any source of external energy. It is a frozen tomb, a museum of its own geology, where every mountain and crater remains untouched for eons. There is no hope for life, no possibility of warmth, and no change except for the slow, relentless cooling as the planet's internal heat slowly bleeds away into the universe. To be stranded here is to be buried alive in the ultimate silence and cold, a prisoner in a gravitational cell drifting through an infinite, starless night. The silent, frozen eternity of a rogue planet is the polar opposite of another cosmic horror, a place where existence is defined by a surfeit of everything. Deep within a hypergiant star like V Canis Majoris, a stellar heart beats with a violence that dwarfs all previous cataclysms. This is not merely a star, it is a cosmic forge of unimaginable scale, so vast that our entire solar system out to the orbit of Saturn could fit inside it. At its core, the pressures are so immense that they defy all terrestrial comparison. The weight of the star's own outer layers, bearing down with the mass of dozens of suns, creates a crushing density and a temperature of hundreds of millions of degrees. Here, nuclear fusion is not the stable process that powers our sun. It is a frantic, desperate, and chaotic inferno. Atoms are not just fused, they are slammed together with such force that they create elements far heavier than iron, a process that consumes more energy than it releases. This creates a wildly unstable core, a furnace that stutters and flares in a desperate battle against its own gravity. The energy produced in this frantic struggle does not simply radiate outward in a gentle flow. It creates titanic convection currents like boiling water in a pot the size of a solar system. Bubbles of plasma larger than entire stars form, rise, and then collapse, generating shockwaves that reverberate through the star's interior. These are not mere rumbles, they are continuous, planet-shattering detonations propagating through a sea of incandescent gas. To be inside this maelstrom, even for a fraction of a nanosecond, would be an end more thorough than any black hole could provide. There would be no spaghettification, no slow freezing. Every atom of your being would be simultaneously blasted apart by the shockwaves, crushed into a new, exotic form by the pressure, and then incinerated into a fundamental particle soup by the heat. You would not just die, you would be unmade, your very components forged into something else in the heart of a star that is quite literally tearing itself apart from the inside out. This is the universe's most spectacular and short-lived type of star, a brilliant, self-destructive giant living on a scale we can barely comprehend. That stellar forge is a monument to finality, but the universe also holds dangers in places of pure creation. Orbiting a newborn star, a protoplanetary disk is a beautiful, swirling whirlpool of gas and dust that hides a brutal reality. This is the violent nursery where planets are born, a cosmic construction site where the raw materials for new worlds are ceaselessly colliding and merging. The disk itself is a vast, flat plane, like a gigantic vinyl record spinning around a brilliant, young stellar infant. But this is not a gentle, orderly process. It is a chaotic shooting gallery of unimaginable scale. The disk is filled with countless planetesimals, chunks of rock and ice ranging in size from small pebbles to miniature worlds hundreds of miles across. All of them are trapped in orbits around the star, constantly crossing paths at phenomenal speeds. Collisions are not occasional accidents, they are the fundamental mechanism of growth. These impacts are not gentle nudges, they are high-speed crashes occurring at tens of thousands of miles per hour, releasing enough energy to vaporize rock and melt metal in an instant. Any object trying to survive here would be pummeled relentlessly, shattered and reassembled over and over again by these titanic collisions. Meanwhile, the newborn star at the center is a tempestuous child prone to violent tantrums. It unleashes blistering waves of ultraviolet radiation far more intense than the light from our mature sun. This radiation bathes the entire disk, stripping atoms from the surfaces of dust grains and boiling away the atmospheres of any fledgling worlds that dare to form. And lacing through this entire chaotic environment are powerful, twisted magnetic fields. These invisible lines of force can accelerate charged particles to devastating speeds, creating invisible currents of lethal energy that flow through the dust and gas. To be inside a protoplanetary disk is to be trapped in a perpetual, hyperviolent storm where you are simultaneously being bombarded by mountain-sized projectiles, scoured by searing radiation, and torn at by invisible magnetic forces. It is the universe's most dangerous workshop, a place where the beautiful worlds of tomorrow are forged in a crucible of absolute chaos. The chaotic violence of a protoplanetary disk eventually gives way to a far more precise and rhythmic form of danger. A pulsar is a neutron star that has perfected its rotation, spinning at a significant fraction of the speed of light. This rapid spin, combined with its unimaginably powerful magnetic field, acts as the universe's most powerful generator. The field channels the star's immense energy into two narrow beams, shooting out from its magnetic poles like the focused rays of a cosmic lighthouse. Because the star's magnetic axis is often tilted away from its rotational axis, these beams sweep through space with every rotation. From a distance, this creates the iconic, perfectly timed pulse of radio waves that gives pulsars their name. But this beautiful, rhythmic clockwork masks a lethal reality. To be a planet or a spacecraft caught in the sweep of one of these beams is to face a periodic apocalypse. As the beam passes over you, you will be subjected to a concentrated blast of X-rays and gamma rays of incredible intensity. It would be like being scanned by a searchlight of pure radiation, a death ray that flickers on and off with the precision of an atomic clock. For a few moments, the environment would be relatively calm. Then, with the inevitability of a ticking metronome, the sky would blaze with an invisible, sterilizing light. This is not a constant barrage, but a rhythmic, predictable scrubbing of any complex matter in its path. The surface of a world caught in this beam would be periodically baked, its atmosphere stripped away pulse by pulse, its chemistry broken down by the relentless, timed strikes of high-energy radiation. It is a danger governed by a perfect, unwavering rhythm, a celestial scythe that swings through the darkness with the regularity of a heartbeat, systematically erasing any possibility of life with every single turn. Deep within the ice giants Uranus and Neptune, the very definition of an ocean is rewritten. Far below their outer layers of swirling hydrogen and helium lies a mantle that is not rock, nor is it any water we would recognize. The pressure here is millions of times greater than the air pressure at Earth's surface, a force so immense it compresses water molecules into a bizarre, fourth state of matter known as superionic water. Imagine a form of ice that is simultaneously a solid and a liquid. In this hot, black ice, the oxygen atoms are locked into a rigid crystalline lattice, a solid scaffold. But the hydrogen atoms, stripped of their electrons, are set free to flow through this oxygen cage like a liquid metal. This creates a substance that is both structurally solid and electrically conductive, a flowing ice that can carry immense electrical currents. This is not a tranquil sea. It is a churning, turbulent fluid layer mixed with toxic ammonia and methane, a chemically hostile brew under unimaginable strain. The heat and pressure within this mantle generate colossal convection currents, rising and falling plumes of this supersonic soup that are thought to power the planet's bizarre and lopsided magnetic fields. To be immersed here would be to experience a simultaneous and paradoxical death. You would be crushed by the solidity of the ice, dissolved by the corrosive chemicals, and electrocuted by the currents flowing through the liquid hydrogen. It is a deep, dark, and violent realm where the familiar rules of chemistry and physics are broken, creating an internal environment more alien and punishing than the surface of any star. The strange, deep oceans of ice giants give way to an entirely different class of cosmic object, a world that cannot decide if it is a star or a planet. A brown dwarf is a failed star, a cosmic in-between that never gathered enough mass to ignite the sustained nuclear fusion that defines a true star, yet it is far too massive to be a peaceful, solid world. It exists in a perpetual state of frustrated potential, and its atmosphere is a monument to that inner turmoil. Imagine a sky that is a perpetual planet-wide hurricane. The upper layers of a brown dwarf's atmosphere are a churning chaos of powerful winds, where storm systems larger than Earth rage for decades, and the clouds here are not made of water vapor. The temperatures, while far colder than a true star, can still be hot enough to vaporize metals. The skies could be filled with clouds of molten iron and silicate rock, condensing into droplets of liquid metal that fall as burning metallic rain. This rain would never reach a solid surface, instead evaporating back into the scorching haze lower in the atmosphere, only to be lifted once more to begin the cycle again. It is a world with a liquid core of degenerate matter, but no true surface to stand on, just an endless, thickening fog of hot gases and corrosive vapors that eventually becomes as dense as a liquid. To descend into this atmosphere would be to experience a slow, grinding end. You would be simultaneously crushed by the increasing pressure, scoured by sand like particles of silicate, and melted by the superheated metallic winds. This is not the clean incineration of a star, but a messy, turbulent, and chemically violent environment, a permanent and angry twilight in an object that never quite achieved its stellar destiny. Our galactic center is a cosmic battlefield of overlapping threats. Beyond the supermassive black hole's accretion disk, this region is a stellar megalopolis packed with millions of stars orbiting at dizzying speeds. In this dense core, the average distance between stars is a mere fraction of a light year, a terrifying proximity compared to the vast emptiness of our own solar neighborhood. This creates an environment of pure gravitational chaos. The relentless pull from so many massive bodies in such a small space sends stars on wild, unpredictable paths, like a billion marbles rolling around in a tilted bowl. This dramatically increases the chance of stellar collisions or near misses that could fling entire planetary systems into the void. The sky from a hypothetical world here would be a perpetual, blinding daylight, lit by a continuous canopy of brilliant, massive stars. But that light is a lie, for it carries a constant, invisible poison. The radiation from countless stellar nurseries, supernova remnants, and hyperactive pulsars creates a permanent, lethal background haze of X-rays and gamma rays. This is not an occasional storm, but a ceaseless downpour of high-energy particles that would make the very concept of a protective atmosphere meaningless. Any fragile life that somehow emerged would be immediately sterilized by this unending radioactive fog. This is the universe's most hostile metropolis, a place where stars live fast, die young, and leave behind a legacy of absolute destruction. Even the chaotic core of our galaxy seems almost placid compared to the raw power of a quasar. These are the most luminous objects in the entire universe, the blazing hearts of distant galaxies where a supermassive black hole is actively feasting. The brilliance comes from the accretion disk, a whirlpool of doomed matter glowing with the heat of billions of suns. But the true engines of destruction are the quasar's jets. These are colossal, focused beams of plasma erupting from the black hole's poles, stretching for hundreds of thousands of light years into intergalactic space. The material within these jets is not simply hot, it is accelerated to over 99% of the speed of light, becoming a relativistic firehose of pure energy. To be anywhere near the path of such a jet is to face an apocalypse beyond any supernova. There would be no dramatic collision or explosive sound in the vacuum of space. Instead, you and your ship would be silently and instantly transformed. The sheer kinetic energy of the particles, each one moving with the force of a nuclear bullet, would blast your atomic structure into a cloud of disorganized subatomic particles. You would not burn, you would not melt, you would simply cease to exist as matter, vaporized into a fleeting burst of new, high-energy radiation. These jets are the universe's ultimate blowtorches, capable of punching through entire galaxies and sculpting the cosmos itself on a staggering scale. A stark reminder that some forces are not just dangerous, they are fundamentally transformative, erasing and reshaping reality on a galactic plane. This brutal tug of war between fire and ice creates a planet of permanent, violent weather. Imagine a world where the very air is a weapon, caught in a desperate struggle to equalize the impossible temperature difference between its two faces. On the star-facing side, the hemisphere is a global magma ocean, its rocks boiled into a perpetual, incandescent sea. The atmosphere here is a superheated plasma, stripped and thin. On the opposite, dark side, the air itself has frozen solid, collapsing into a continent-spanning glacier of oxygen and nitrogen ice. But the true battlefield is the thin ribbon between them, the Terminator line. Here, the atmosphere screams. The superheated air from the day side races towards the freezing vacuum of the night side, driven by a pressure differential that makes Earth's most powerful hurricanes feel like a gentle breeze. These are not winds you can stand against. They are a horizontal river of gas moving at several times the speed of sound, a perpetual shockwave scouring the landscape. Any mountain range would be sandblasted into smooth, polished glass in a matter of centuries. This is a world with no seasons, no dawn, and no dusk. If you were to stand in that narrow, turbulent zone, you would see a sun that never moves, forever fixed at the horizon, casting long, unmoving shadows across a landscape being torn apart by a hurricane that has raged for billions of years. It is a terrifying vision of a planet trapped by gravity, a world where the weather itself is a relentless, global apocalypse. This frantic starbirth does not happen in emptiness, but within colossal, dark nurseries known as molecular clouds. These are among the coldest places in the galaxy, vast regions of gas and dust so dense they block the light from the stars behind them. Within their shadowy depths, gravity slowly pulls the material together, creating the seeds of new suns. But in a starburst region, this process is thrown into hyperdrive. The cloud becomes a frantic, overcrowded maternity ward for stars, and that is the source of its lethal nature. The greatest danger comes from its own children. The most massive stars that form here live fast and die young, blazing with a ferocious intensity. They flood the cloud with an unending torrent of ultraviolet radiation, so powerful it strips electrons from atoms, ionizing the gas and tearing the cloud apart from the inside out. This creates vast, expanding bubbles of scorched, empty space surrounded by walls of glowing plasma. Meanwhile, the shortest-lived of these massive stars explode as supernova. The shockwaves from these nearby detonations slam into other quiet parts of the cloud at thousands of miles per second. This is not a gentle nudge, it is a cosmic hammer blow that violently compresses the gas, triggering a new, chaotic wave of star formation in a self-perpetuating cycle of creation and destruction. To be inside such a cloud is to be trapped in a beautiful but lethal feedback loop, where the very act of giving birth to stars ensures the nursery's own violent demolition. It is a cosmic engine of relentless change, where the future of entire star systems is forged in a storm of searing light and world-shattering pressure. The planet Mercury offers a different kind of violence, a slow and systematic grinding under the weight of dual extremes. Its surface is a battlefield of temperature, scarred and pockmarked under a sun that appears 3 times larger than it does from Earth. With virtually no atmosphere to act as a blanket, the planet's surface is completely exposed. During the long Mercurian day, which lasts for about 88 Earth days, the ground bakes under relentless solar radiation. Temperatures soar to 800 degrees Fahrenheit, hot enough to liquefy lead and turn zinc into a shimmering pool. The rocks themselves glow with absorbed heat, and any metal object would quickly become too hot to touch, transferring that scorching energy with devastating efficiency. Then, as the planet slowly turns, that same landscape plunges into a night that is equally long and infinitely colder. With no atmospheric blanket to trap any warmth, all the accumulated heat radiates unimpeded back into the blackness of space. The temperature plummets to nearly 300 degrees below zero. This is a cold so profound it makes the polar ice caps of Earth feel balmy, a deep freeze that would instantly shatter most metals and turn any gas into a solid. This daily cycle is a thermodynamic torture, expanding and contracting the very rock of the planet over eons, creating a surface crisscrossed with giant scarps and cliffs as the global crust wrinkles and cracks. And through it all, without an atmosphere to burn them up, a constant, silent rain of micrometeorites peppers the landscape, sandblasting the terrain and leaving it a barren, airless wasteland. This is not a world of storms or oceans, but one of stark, simple, and absolute exposure, a testament to the universe's indifference to the fragile concept of moderation. Even a world of apparent purity can hide a corrosive heart. From the gleaming, white shell of Saturn's moon Enceladus, magnificent plumes of water ice erupt hundreds of miles into space, creating one of the most beautiful sights in the solar system. These brilliant geysers scream that this small moon is far more than a frozen ball of rock. They are the direct evidence of a vast, global ocean of liquid water trapped between its rocky core and its thick, icy crust. For scientists searching for habitats for life, this is an electrifying discovery. Yet this same water carries a hidden danger. The plumes are not just made of pure water ice. Spectrometers have detected a cocktail of complex organic molecules within them, the same carbon-based building blocks that are essential for life as we know it. But these organics are mixed with other, more sinister compounds. The plumes also contain ammonia, methane, and salts, a chemical brew that suggests the water is in contact with a rocky seafloor, a place where hydrothermal vents might be leaching minerals into the ocean. This creates a deeply paradoxical environment, a potential cradle for life that is simultaneously a toxic soup. The very forces that create this ocean are also tearing the moon apart. Enceladus is caught in a gravitational tug of war with Saturn and its larger moons, a process that flexes and stretches its interior. This tidal friction generates the heat that keeps the subsurface ocean from freezing solid, but it also puts the entire world under immense, unrelenting stress. The plumes themselves are not gentle steam vents. They are violent cryovolcanic eruptions blasting through fissures in the icy crust known as tiger stripes. These fractures are being constantly squeezed and pulled open by the tidal forces, acting as pressure release valves for the ocean below. This entire system is a delicate and volatile balance. A slight shift in the moon's orbit could intensify the tidal heating, turning the gentle flexing into a catastrophic rupture, or it could cease altogether, allowing the entire ocean to refreeze into a solid, permanent tomb. The beauty of Enceladus is the beauty of a high-pressure valve on a cosmic boiler, a world where the potential for life is forever balanced on the edge of geological violence. From the solar inferno of our own star to the silent, frozen abyss between galaxies, we have journeyed through a universe of spectacular hostility. These 25 places are not science fiction. They are the real and present dangers that fill our cosmos, each a testament to physics pushed to its absolute, terrifying limit. They remind us that the universe is not a serene void, but a dynamic and often violent arena where stars are torn apart, space is twisted into knots, and entire worlds are forged in crucibles of chaos. This grand tour of cosmic danger highlights a profound and humbling truth. Our peaceful blue planet, with its stable climate and protective atmosphere, is an extraordinary rarity. It is a sanctuary of delicate balance in a cosmos that is overwhelmingly hostile to life as we know it. We exist on a fragile island of calm in a sea of unimaginable ferocity. So we turn the question to you: which of these dangerous places left you the most awestruck or unsettled? Was it the relentless radiation of Jupiter, the time-bending horror of a black hole, or the silent, freezing eternity of a rogue planet? Share your thoughts in the comments below, and if you enjoyed this deep dive into the universe's most lethal locations, be sure to subscribe for more journeys into the greatest mysteries of space.